now should have y is equal to negative 2 over x squared plus 2. Ariella, can you grab the lights for me, please? Now, what we already did, I think, oh, who was it? Was it Jordan? Someone said, what we notice here now is we have an x squared in the denominator, and we haven't had that. We have just been graphing basic rational functions. We're still going to go about this all the same way. So our first step is we're going to find this vertical asymptote. So step 1, VA. Now, some of you could probably do this in your head. I'm not going to do this step in my head because I do have an x squared. It's not as simple as a linear equation where it's just an x. So I'm going to set x squared plus 2 equal to 0. Okay? And I need to solve for x here. So when I solve for x, what's going to happen? I'm going to get a negative x, or x squared is equal to negative 2, right? And then what happens there? I have to square both sides. And what do you notice? I get an I. Very good. I have an imaginary number. Can I graph a vertical asymptote on the xy axis that's imaginary? No. Okay, so we're going to say because it is I times the square root of 2, there is no vertical asymptote. There's no vertical asymptote, so there's no all x values will work is what it's saying. We can plug in any x value we want into this x squared because what the vertical asymptote is telling us is we can't have an x value there. Does that make sense? Okay. Step 2, we're going to go for that x-intercept. Well, if I plug 0 in right here at that y and I do cross multiplication, what happens to the denominator? Right? 0 is equal to negative 2 over x squared plus 2. And I cross multiply. I get negative 2 is equal to, and what happens to this right there? 0 times anything is what? 0. Do I have an x-intercept? No, there's no x-intercept. This graph does exist. Well, now we're in luck. We do have a y-intercept. What is my y-intercept going to be? How do you know that? Very good, Jack. When you plug in y is equal to negative 2 over 0 squared plus 2, you get y is equal to negative 1. Now, do I want you to write it as y is equal to negative 1? Yeah, it's a point. It is not a line. So you can either write it as 0, negative 1, or that your y-intercept is negative 1. Step 4, my horizontal asymptote. What is my horizontal asymptote? How do you know it's 0? Degree is 0 on top, 2 on the bottom. 0 is less than 2, so the degree of the numerator is less than the degree of the denominator. It's always y is equal to 0. So my horizontal asymptote is y is equal to 0. Now we need other points, but before we get our other points, let's graph what we have. Okay, so what do we know? We know that we have a horizontal asymptote at y is equal to 0, so there's y is equal to 0. We know that we have a y-intercept at 0, negative 1, and that's all we know. So we're going to need a lot of points here to kind of figure out what this graph looks like. So in order to save us time, I'm going to assign each row an x value, and you're going to figure out what the y value is. Let's start with negative 4. Vincent's row will be negative 4. You're going to plug -4 into our original function up here, -2 over x squared plus 2, and you'll get a decimal, so you give me that decimal. Emma's row, I want you guys to plug in -2. Alec and Yanni, you guys do 0, okay? And we already did 0, so we know it's what? -1, so let's assign you guys 1, okay? Sierra's row, let's have you guys do 2. Matthew's row, let's have you guys do 3. Okay, and then Brenna's row, you guys do 4. So right now what everyone is doing is you're taking your x value, you're plugging it into your calculator, and how are you plugging it in? Just be really careful. In your calculator, if you're going to plug it in all at once, make sure you have -2 divided by parentheses x squared plus 2. If you're watching at home because you've been absent, why don't you pick a couple values and do that as well? All right. Vincent, let's get someone from Vincent's row. Vincent, did you get it for -4? 142? Is that what you guys got as well? Let's confirm. 0.142? Yes? Ariel, did you get that? Did you get it, Brianna? Someone? Okay. 0.142. -2. Oh, short gunner, what'd you get? -1/3, so 0.3. Repeating. We have -1. 1. Alec, what did you get for 1? -2/3. Is that what you got as well, Yanni? Okay, so -0.6 repeating. Okay. Was this -1/3 right here? And then Vincent, was yours negative as well? It was negative? Okay. Okay, let's try it here. So we're stuck on the -4 right now. So that would be -2 divided by 16 plus 2, so that's 18. And that gives you -0.1. So that's okay. It was probably just a little mistake. Are we okay so far? No. So -0.1, -0.3, -1, -0.6, 2. Whose row was 2? What'd you guys get? Someone in that row, Sierra? Or -1/3? Okay. 3. Matthew's row. Someone. What'd you get? Stuart, did you get it? -0.18. Okay. 4. Brenna's row. What'd you guys get? The same thing as what? -0.1. I'm okay. -0.1. What do you guys notice about these numbers? They're all what? They're all negatives. Our domain or our range is going to be y is less than 0. Let's graph this then. And I'm going to actually erase this here. We get out soon, don't we? Oh, I do need an assistant now. Why am I going to erase this right here? Guys, why am I going to erase this? What do I notice? My point is at 1. Well, all these points are what? Yeah, so I'm going to make it a little bit bigger. I'm actually going to go by, what should we go by? Maybe by 0.2s. So I'm going to call this -0.2, 4, 6, 8, and this is -1. Does that make sense why I'm doing that? Otherwise, my numbers are going to be so scrunched, you guys. So I kind of want to examine my range and say, how do I want to scale this so I actually see what's going on? Well, I know at 0, -1, I have a point, so I'm going to mark that right away. And then I'll start with -4. At -4, -1, -2, -3, -4. I'm at -0.1, so I'm about right here. At -2, I'm at -0.3, so I'm approximately right here. At 0, -1. At 1, I'm at 0.6 repeating, so I'm approximately right here. At 2, I'm at 0.3 repeating. At 3, I'm at 0.18. And at 4, I'm at 0.1. Now, what I would do right now then is I would go to Desmos and see exactly what it looks like just to help you out, and I'd plug it in. We don't need to do that now because we don't have the time, and I trust that you guys know how to use Desmos now. We've used it so often. But you know it's not going to cross this line. It's going to approach that asymptote, and it's going to go down and around and back up. And that's my graph. So you want a lot of points so you really know what that picture looks like. We get out at 19 today because it's an advisory day, so let's do one more today, and then I will give you a shortened assignment. Okay, does that sound okay? Yes? Okay, let's do it. We're going to go a lot faster this time, though, so please raise your hand if you need help or if you need me to slow down, and then also I'm going to ask for help again with these points. Okay, we have y is equal to -x² over x² minus 4. The first one is that vertical asymptote. I have x² minus 4 is equal to 0. Now we have a quadratic here that we need to solve. We can use algebra like we did last time. What other ways can you solve a quadratic? We can factor it. I always try to factor first today when you're doing your homework. You can also use the what? The quadratic formula to solve. When I solve this, I could factor this as perfect squares, or I could just use algebra by bringing 4 to the other side, and I take the square root. And what do you get your x equal to? Not only 2, -2 plus or minus 2. What does this mean for our vertical asymptote? Yeah, we have 2 vertical asymptotes. We have one at 2 and one at -2. Next, our x-intercepts. When I plug 0 in for y, what happens to the denominator when I cross multiply? Did I hear someone say it what? Yeah, it goes to 0. So I just care about this numerator is equal to 0. -x² is equal to 0. What is x equal to for my x-intercept? 0, yeah. If my x-intercept is 0, what's my y-intercept? It's also 0, okay? And when I plug 0 in for x, you can see that. My horizontal asymptote. What do you notice about the degree of the numerator compared to the degree of the denominator? They're the same. So we take a ratio of the leading coefficients, which is -1 over 1. And what is that equal to? Very good. You guys are doing excellent. So my horizontal asymptote is equal to y is equal to -1. I'm now going to graph each piece. Okay. I have a vertical asymptote at -2 and +2. +2. I have an X and Y-intercept at the origin. I have a horizontal asymptote at -1. And now I need your help, you guys, so we can finish this problem off. We need to figure out what this looks like. I need lots of points. I need points to the left of the vertical asymptote. I need points in the middle of the vertical asymptotes. And I need points to the right. I'm going to pick -3 and -4. So Vincent's row, why don't you guys do -3? Emma's row, you guys do -4. Alec and Yanni, I want you to do -1 and 1. Okay. Sierra's row, I want you guys to do 3. And then Matthew's row, do 4. And then Brenna's row, you guys actually just do 1. And Yanni and Alec can do -1. So what am I doing with my X values right now? I'm plugging them in to my calculator, -x² over x² minus 4. While you guys are plugging them in, I'm going to quick look at the assignment and I am going to shorten it for us. So give me a second. All right, are we getting close? We have 4 minutes before the bell rings. And like I said, I'm going to shorten this assignment for you guys. All right, ladies and gentlemen, I'm hearing you chat. So negative, and I'm going to ask for people to confirm. Okay, so -3². Think about this, guys. Now watch out. You want to do the exponent first. So -3², this is going to be +9, but then +9 times that negative, right? Okay, so Brianna, what did you get when you plugged -3 in? Ariella, what about you? 1.8? -1.8? Can someone else confirm? -1.8? Okay. Now, -4, what about this row? -4/3. Can someone else confirm? -1.13.
Well, I mean, they're the same thing.
Yeah, it's negative because we're 4 and we got 4 -4.
Wait, but
Okay,
we're doing it the way you have
it's okay. I'll plug it in and see. Here, I have it.
it's -16 of 12.
Give me a second, okay?
Yeah, it's the same thing as -4/3.
Okay, so I can quickly do this for us with using the graphing calculator. Okay. Okay, guys, we need to calm down, especially people watching at home. They might be like, what's going on in class right now? I have the way with my graphing calculator, I can quickly put it in. So I have -3, we should have gotten -1.8. -4, you should have gotten -1.3 repeating, which is -1 1/3. -1, you should have gotten 1/3. 1, you should have gotten 1/3. 3, you should have gotten -1.8. And 4, you should have gotten -1.3 repeating. Okay, what does this look like? Okay, so at -3, which is right here, we have -1.8. So I'm going to make my 1 and 2 pretty big there. And -3, 1.8 is about right here, almost at the 2. -4 is a little below it. What this is going to look like is it's going to look like yesterday. Now you can plot more points or use decimals if you need help. Okay? Yes. Oh my gosh. And I'm taping this to you guys. How embarrassing. Should I still upload it?
Yes.
Thank you, Sierra, for saving the day. You got a shout out now in the video. Okay.
Yes, you're up.
-3, -1.8. Then we're here, right? So it's going to look like this. Oh, and that's the bell. We will finish this tomorrow. No homework, okay? If you compare to Mrs. Krupsted's class, know that she'll have homework, but we'll have more tomorrow, okay? All right. Have a wonderful day, everyone.